Hello, welcome to our new channel. And the aim of our channel is to provide high quality education online and courses and weekly. Hello, welcome to our and we would like to provide you high quality courses and collaborate with you for to develop some very advanced projects. The aim of our company is to online education and online research focus on chemistry, biology, and physics. So we would like to create an online university where you can develop your own projects and develop also some common projects. The most important is to develop any advanced project focus on innovation. So weekly, I will present you some courses on chemistry, then physics, then biology. Okay. So here we go. Today we will start presenting for at least hopefully 10 hours. We will see. The heterocyclic chemistry. Heterocyclic chemistry is very important in organic chemistry and even in life, because most maybe it represent 60-70% of the compound require knowledge sold in pharmaceutical industry. They use heterocyclic chemistry. So you should even, I should say, you must know the maximum about heterocyclic chemistry. So heterocyclic chemistry is really the cornerstone of organic chemistry. So I will be writing you a book, a French book, by a very good French professor named René Milcent. So I will try to organize, present you and highlight you within 10 hours everything you should know about heterocyclic chemistry. So let's start. Here we go. Okay. Heterocyclic chemistry. Okay. So 1A, definition. Okay. So if you have any question about, if you have any requests and queries, so this channel is to stream online different courses and also different advanced research ideas. Okay, we're using different techniques. If you want something very well presented with PPT, you can go to my other channel, Research Edutica, where everything is prepared with PPT, with nicely prepared. Here we just like stream like randomly some ideas and use some techniques for 10 hours and present some courses for 10 hours without any advanced preparation. So but it's focused by using different resources. So what is heterocyclic chemistry? It means that it's any compound that contains an heteroatom. Heteroatom. Okay. What they mean by heteroatom? It can be X equal nitrogen, oxygen, sulfide, selenium, and so on. Okay, so it could be a compound that is linear or cyclic. So this is all the heterocyclic chemistry. So maybe next week I will focus more on the newest, the most recent, more recent discovery in heterocyclic chemistry. Okay, so this is a traditional, what I should call a traditional heterocyclic chemistry. Okay, here we go. Okay, so it's any compound with, okay, no matter, it could be acyclic, cyclic, or cyclic. Okay, and it could be even free. Okay, let's start from free. So some example, you have to keep in mind two things before we start really um, 3 4 5 member ring, about the stability. Five member ring are more stable than 6 member ring, more stable than 3 member ring, then etc etc. Okay, it's the order of stability in average, in general. Okay, it's not always it's in average, it's like this. Okay, there are other factors that are involved. Let me just check if we are online, because it's my first stream. Give me just 2 minutes. Please give me just 2 minutes. Okay. If you have any question, any project that you want to do to achieve, I mean, our aim, the deepest dream of our deepest dream is to, okay, we are online. Our deepest dream is to provide online courses, very advanced, like something which is really perfect, perfectly focused on academic research and industrial research. I work in the industry, and I have been working in one university. I think the most important is to provide a new approach of science. Like, you learn what's from background to very advanced for a project that you want to accomplish, and we guide you to accomplish this project. Okay, this is our aim. This is, it would be our aim is to create an online university where you can get, I mean, a degree, and you can, most important is to achieve your project. The most important, don't forget, is not to get degree by itself, it's to achieve all the project that can open you new doors. Like, you can use it to create your own company, as you can even, like, it's a university company. Okay, directly related to a company. So let's start, let's go. Okay, running inside. Let's start. Okay, so it can be acyclic, cyclic. So some example, 5 member ring. Okay, some example of 5 member ring. It could be conjugated or not. Okay, pentazole. When you have a ring like this, it means it's conjugated. Okay, that means a ring like this. Oh, sorry, I don't draw well. Equal, it's a ukel. Okay, this one is named ukel. It's a very famous German professor. So it's conjugated, that means it can be delocalized, so we will put, that means it's conjugated. Okay, that means it's dynamically moving among the cycle. Okay, so pentazole, Our company, I mean, our aim is to push everybody to their limits. That's why I'm streaming 10 hours. So every weekly we stream 10 hours. So this week is heterocyclic chemistry, next week heterocyclic chemistry, then we will go to chemical biology, biology, synthetic biology, everything. So if you want a very clean, again, if you want a very organized, perfect courses, you can watch our Udemy or my other channel, Research Edutica. It could be unsaturated, okay, unsaturated or saturated. You don't have double bonds such as piperidine. Oops, let's go piperidine. Piperidine. Sorry, I made a mistake. Unsaturated. Saturated, that we don't, you don't have. It's opposite. I'm wrong. Sorry. Saturated. Oop. Unsaturated, that means saturated, that means you have a double bond. Okay. Oops. And unsaturated, no double bond. Like piperidine. Okay. So saturated, saturated equal double bond. It has at least one double bond. Okay. Here we go. All right. Some other example, like if I'm remembering, let's do it well. Took N double bond and all right. For example, take trizol. Okay. Another furan. Another example of 5-member ring. Okay. Thiophene. Okay. And another example of six-member ring, like pyridine. Okay. Pyridine. And so on. You know, there are many. So next time I will talk about the nomenclature. The nomenclature I will talk. You know, I told you that I will present another another book. The nomenclature, I will talk about it next time. All right. Some other exotic heterocycles. You can find oxyren. That's funny, you know, that's Very interesting to find. You don't find it. Yeah, you can think about doing some chemistry with this type of motif. You cannot find it easily in a lab, so you can think about some interesting idea projects with this kind of heterocycles. Acetylene. Acetylene, you can find it in penicillin, okay, or the beta lactam. Beta lactam contains this formant bearing cycle. Okay, okay. Other example, aziridine, NH, okay, NH, sorry, maybe. Sorry, like this. Aziridine. Okay. Okay, I guess you want other examples. I can see it. THF, tetra hydro furane. Okay, so there are many other examples you can find. So you understand that an heterocycle is something like this. Okay, it can be it should contain at least one heteroatom like oxygen. Okay, I hope it's clear. So this is few examples, and the list is very long. You have many other examples of heterocycles. So you keep in mind this generic motif. Okay, anything with X is an hetero cycle. Blah, blah, blah. Okay. So I go through the book. Something important, but see, is to detect the symmetry. Why is important? When you will analyze your compounds by NMR, and also for the synthesis, the symmetry is very important in life, in science. Is to detect some symmetrical compound. If, for example, pyridine, what it means the symmetry. You have different type of symmetry. Maybe one day I will talk about the symmetry. Okay, if you don't know all that, I mean, this is not the case for all this type, how to define the symmetry in organic chemistry. So the symmetry, it means that, okay, this one, H1, it means that when you have a symmetry, like here it's a mirror. Symmetry is important also in determination. It has a lot of application in equilibrium, in stability. It has a lot of application. Maybe Jacques Monod talk about Jacques Monod. It's a French Nobel laureate. He worked a lot on the symmetry and and its importance in biology. Okay, maybe we can develop some projects about the effect of symmetry in the selection and the evolution. So H2 prime, they have the same properties. Okay, they are similar by NMR. They have the same chemical shift, same. Okay, H2, H1, H1, H1 and H1 prime. Okay. So the nomenclature, I will talk about it the next time. You have some 1D exotic heterocycles. So you can merge different heterocycles together, like this one and that one. For example, you can have some other exotic heterocycles, such as this one. It's very important to be very creative with heterocyclic chemistry, because you can develop some new materials in chemistry that nobody has done before or thought about it. Like when you explore like this, merging compounds together. Other type of exotic heterocycles, like this one. I like this one. When it's exotic, you can publish it in good journals. Okay, when it's nobody thought about it, you can go ahead. This one is not so exotic, but you can think about other idea. So in other words, you have just to shift the X and create some new system of conjugation. Okay, conjugation. It's called delocalization of electrons. Okay, that means, for example, that typically you can delocalize your compounds along the carbon chain, so it's conjugated. Okay, so now this is a background about heterocyclic chemistry. If you understand that, you have to know that most of the drugs it's everywhere you will see heterocyclic chemistry. Okay, okay, everywhere you have, and it's hydrophobic. That means quite greasy. Most of the drugs, hydrophobic, sorry. Most of the drug is greasy, depending on what they have. Okay, they are not highly soluble, not very soluble in generally. Okay, generally not very soluble, or they self-assemble in particles. Okay, so sometimes that's why you need to add some other compound to dissolve like liposome or other or nano. You can load them on Go nanoparticle or load them on polymer based nanoparticle to do the reaction. Okay, let's start with some reaction for the preparation. And first one reaction that is interesting that we mentioned in the is first two reactions. 2A, how to prepare the compound, this heterocycles. Minsky reaction. So here in 10 hours you are with us, and you can learn a lot, and in the future we can hopefully we have more people. Give me as it's a marathon. Okay, I just come back in 1 minute. All right. Minishi. Okay, Minishi reaction. I have never used it but well, not many people use it, so you should use it. Okay, be unique, be different, and one day you will succeed. Okay, so it start. So they mention the use it's like Fenton reaction to generate a radical. They had like, you should not underestimate this reaction, because this reaction can have a lot of application to create some 3D network. Any type of 3D network. You can think about it. It's very very interesting reaction. Okay, Minishi. So you create, the idea is to create from TBU O2H this radical that can react in the next steps, for the next step. Okay, so you create a radical, then B. This radical can abstract a hydrogen abstraction. Plus, this is a labile hydrogen. Ethyl. Okay, oxygen. So you have that. Tick. Okay, so you form TBUOH plus so you create a cascade of reaction while you generate a new. Oh, how to clean. Oh, sorry. I should draw it. Okay. I should learn. Then you can reacted on other reactive species such as so you start generating some radical that can propagate. For example, can be some activated species like this. So here, let's stop here. Here, it is protonated, okay? So the nitrogen has given its double pair electron. So it's activate its electron poor, electron quite electron poor, okay? Because it has given its electron, the nitrogen. So this position is very reactive. Okay, so it forms. And by the end of the courses, you will be able to do all the most complex natural product. Okay, everything can beat up everything. I guarantee you, if you follow our courses. I mean, also you can do your own way, obviously. Minus, like you need some. It will quench. For example, from if you had ethanol. Okay, it's electron donor. So you get at the end. Sorry, this should improve. Sorry, it's my first time with this tablet. You get this compound. Okay. All right. So it's an addition of a radical to some. It's an typically the Minsky reaction. It's an addition of a radical or radical to pyridine to a derivative of pyridine. Okay. Another example. You can use in this fraction iron 2, silver in some cases. Example where you use silver. Silver depends which state you use. If you use like TB, it's TBU equal. Oh my god, it's 3 methyl. Okay, this is TBU. The most important is not me, it's what we can do all together. Who I am is not very important. You are more important, and the projects are more important. Always you generate a radical, so a radical, and okay, so this is typically the reaction. Okay, this is a product. Its name Minishi. Might be Italian, maybe I'm wrong. All right. In that case, TBU, if I come back to my example, TBU if you have anything that you want to do as project, don't hesitate to contact us and to contact me. We can help you to fulfill your project. This is the most important. Okay, this one. So when you have a radicaler, when it's a radical, you use this arrow. Okay. Okay, always like one side of the arrow. So here it gives, okay, this one. Next time I will use some color. Okay, I will see how I can use some color, or I buy another tablet plus CO2. Okay, this is a gas. And so it should like miniature reaction is more or less some, if it's you use Rn2 to generate a radical. Okay, it should be like a labile hydrogen. Labile, that means to cut. Labile. So another example is to use your TBOH. Okay, you remember TBOH? And TB. Okay, so if you use the same plus, so you remember, okay, addition here in ortho meta, and this is para. Position. Okay. Other example, there are many. You can use a DMF. For example, DMF. It's a solvent. DMF. Labile, that means you need a group that attract electron. Okay, like so something that attracts electron. Another example of mini-shear reaction. You can take back pyridium. You do the same. For example, you use Rn2. Like, so you can start with TbOH plus Rn2. So it's classical Fenton reaction. Fenton reaction, or you generate a radical. Okay, this is a reactive species. Then it can abstract the electron from DMF. Then they do something else. They claim that TBU could form acetone plus CH3 bond. Okay, so it's not so stable according to them. Interesting. So this CH3 bond with DMF can abstract this electron, and you create this reactive species. KDMF. Then this one could react. Okay. So okay, to form this product. Okay. All right. There are many other examples. Most of the time they use iron, so they use if I try to, they use something like this. Okay, they use iron 2 or iron or silver, sorry, 2, silver 2 to create this reactive species. Then this reactive species abstract one electron, then interact in an activated heterocycle. All right. This is Minichi reaction. Okay, Minichi reaction. Catalyzed instead of catalyzed with palladium. So don't worry, because it's old. It's quite old chemistry. So there are many advances that has been done. That's why I need to update. It's always nice to study the old chemistry and the new chemistry. I can give you an example of why it's important to consider the old chemistry, like typically this reaction. Okay. Oh, sorry. This type of reaction was developed by, there was some paper, I mean not exactly this one, but it was used by Caroline Bertozzi. She used like this triple bond, activated triple bond to promote minus to do cyclo addition. Okay, and in Wittig published an old paper like this. He reports that it releases a lot of heat, but he didn't know what it is exactly. So Caroline Bertozzi used it to do click chemistry and to find orthogonal chemistry without metal, no metal. So it's always interesting to study the old chemistry and the other old way of education, because old way of education, what I like, they are very rigorous with the mechanism. Okay, let's make a small stuff. 5 minutes. 5 minutes. I come back in 5 minutes. Okay, thank you. I'm back with this nice reaction. Mm. Okay, so I'm back with the palladium reaction. One thing you have to know, you have to keep in mind, it's something which is very important in organic chemistry, the reactivity, order of reactivity. First thing that you should see, consider in heterocyclic chemistry and organic chemistry, the acido-basic reactions are fast. So if you have, for example, ROET, you have an acidic, okay, the pK. So it can deprotonate, it deprotonates fast, okay. First thing, acido-basic reaction are the fastest reaction, it's quite immediately, very fast, quite few seconds to get this species, okay. So always when you have two reagent, always check the first step if you don't have this, if you cannot, when you had some reactant, check if you can do it firstly, okay. It's very important to reagent, check if there's some possible chemical, I mean acid-basic reaction. Okay, let's come back to our study of palladium. Oxidative. So we talk about the oxidative addition. So we take some aromatic, okay, plus palladium 0, to give this intermediate trick. So it's better to put X here. Some X like boron, bromide, iodide, chloride, chlorine. To form an activated species. Sorry. A reactive species like this. It's very interesting to work with this reactive species. You can think about then first oxidative. This is a step oxidative addition. Oh, sorry, oxidative addition. First, second step is insertion because it's not stable. Okay, it's very reactive, very reactive. So insertion. Here we go. You need like a double bond, like it's an egg reaction. So if you take your AR palladium X, it's named egg reaction. So for example, so you have an assertion. Then it leads to this reactive species in domino. Insertion of the palladium alpha in a beta position, okay, gamma. Why at this position and not? Because palladium is more stabilized at this position. I should solve this question. Addition. It's maybe it's more stable at this position. Then you can add something else. If you can do even domino, okay. You can add other species, okay. Or you get an elimination, or you can continue adding some double bond. If you have other double bond, you have ascension or ascension. So this type of you can do its name scene elimination. Oops. Double bond plus all right. Okay, some examples. Of egg reaction, typically, if you have this indole, double bond. Okay, if you add palladium 0, addition, oxidative addition, insertion, elimination. Okay, so you get this product. Sorry, I'm not good at all at drawing. I try. Sorry for that. That one. Okay. Okay. If you had any source of palladium 0, you get from this one. Get this product, okay? All right. The bromine, the position of the bromine direct the position of the addition. One thing, keep in mind that something, be careful, it can work also intramolecularly, okay? Like this, intramolecular. Check always that intramolecular reaction. Everything that I'm going to show you can work also intramolecular. Intramolecular reaction is something that you keep in mind. Are more favorable than intermolecular reaction. Okay. Why people had the base to regenerate the palladium? You need to have the base to have a cycle, you know, like a cycle. People, they had a base, palladium 2 Pr plus a base, because this is a reactive species of palladium. Palladium should be palladium 0 to do oxidative, to perform oxidative addition. Okay, so you need like a base, because I remind you, on the Eke reaction, here you need a base to regenerate this product and recycle the palladium. The Eke reaction also work sometimes with, instead of X, in some cases, iodine, bromine, triflate, tosylate, and sometimes hydrogen, depending on the energy barrier. All right. Another example. To close, for example, to close this ring, by using palladium and Euroflux, you can close the ring. Acidic acid, use acetic acid. Intramolecular version, okay? Intramolecular. Always check if you cannot do it. So first check if you cannot, always for each step, okay? You have to check if you cannot do some intramolecular version of the reaction. All reaction can be intermolecular or intramolecular. Check the acido-basic reactivity. Then you can also check other things. I will let you know during the courses. I come back. I have to do, just give me 10 minutes, please. And we continue these courses. Okay. So I propose to stop first this part of the video. I will come back later to continue how 10 hours. Okay. Thank you. Sorry.